So hi and welcome back to Next Level Sim Gaming. And first of all, I'd like to say a huge thank you to everyone. The channel has now passed 10,000 subscribers, which is absolutely amazing. And I'm now working with some great new partners too, SimHound and SK Hynix. So some of our exciting new products coming soon. And I also want to say a huge thank you to Michael Hurst, my music producer friend, who created the intro music for this channel. And if you need anything similar for your projects, then there are links to his channel in the video description. So coming up in this video, we're going to be looking at how to undervolt your CPU correctly. I've had a lot of amazing comments about how the tuning guides have helped get your PCs running better than ever. But one question that keeps coming up is, how do I know the correct settings for my PC? So let's get straight to the video and we'll show you how. So hello and welcome to another video. So in this video what we're going to be showing is how to apply and set the correct undervolt and test the undervolt accordingly. But for those of you who haven't seen the previous videos, we're just going to run through the actual undervolting process once again. So into the BIOS we would reset back to factory defaults by pressing F5 first of all. We then need to select the search function, which is selected by pressing F9. First thing we need to do is we need to disable undervolt protection by typing undervolt in the box just here, and then we'll select disable just by the pull down option just here. We need to disable Intel virtualization technology. Once again, same process, search and then just disable in the pull down box. Into the main BIOS section, the AI tweaker section, we then need to select the Asus advanced overclock profile. We then need to set the multi-core enhancement to auto. Then we need to disable the Intel Adaptive Boost technology. We then need to move on to the AI overclock tuner and we need to select our desired XMP profile. So I'm using XMP tweaked at 1700 megatransfers. Onto performance core ratio, we need to synchronize all cores. We need to set the all core ratio limit to 55. We need to then move on to the load line calibration. In DigiVRM, select level 4 recommended for overclock. Onto internal CPU management, so we now need to disable the unlimited ICC max. We then need to set the current core cache ratio limit to 400 amps. Then set the power limit 1 to 253. And the power limit 2, which is the short duration, to 253 as well. Onto the IA current excursion protection, we need to set this to disabled. Onto the IA VR voltage limit, we need to change this from auto and set this to 1450, which will set the vid max to 1.45. We then need to set our underclock, so we then move on to the global core SVID voltage. We would change this from auto to adaptive mode. But we need to select a negative offset, so we are undervolting, not overvolting. And then we go to the offset voltage. In this example, I'm using minus 0.070, but we're going to move on to how we set this figure in a moment. In the fan configuration, just set the desired fan profile. Remember, when we are undervolting or overclocking or benchmarking, we would have the onboard RGB software. In this instance, I use Corsair, so I will be disabling the Corsair software while we are benchmarking and undervolting and testing. Once we're happy with everything, we would then move on to exit and save changes and reset. And then in this example, you will see that the settings that were changed will be represented in here. So by moving on to the Asus overclock BIOS profile, it would have made various changes in here. The other changes are the ones that we manually set. So there's been a couple of questions regarding a couple of these settings. So for instance, why do we disable Intel virtualization technology? Why do we disable undervolt protection? Well, undervolt protection is required to be disabled to apply an undervolt. The actual Intel XTU program we're going to be using in a moment won't allow it otherwise. And also Intel virtualization technology is required to be removed so that once again Intel XTU can run. So just scanning through the settings here just to make sure that we're happy with everything and we've applied all relevant settings. Once we are happy with that, then we can simply move on to select OK, at which point your PC will reboot into Windows. So we are undervolting and testing on an Intel i9-14900K. Results may vary based upon different processors. So this is an undervolting and tuning guide, and today we're going to be using the Intel XTU application to make changes and also to run stress testing. So into the Intel XTU tuning utility, you may be familiar with this from previous videos, you may not. This is the latest version, and thanks to the channel contributor in May for pointing out the updates to this application, and the video is based upon the latest software updates. So in Intel XTU, when we would choose advanced tuning, this is where we'll set our undervolts, and first thing you need to do is click through the disclaimer. You can see once in here we're looking at the core voltage offset, and the core voltage offset is presently set to a negative figure of 0.050. I would recommend that everybody set their offset to begin at minus 0.050. Most systems will be able to handle well in excess of that. However, as a starting point, it's a completely safe level that your CPU will be more than capable of handling. So just highlighting the offset just here. So once we've applied our offset, what we then need to do is we need to run a stress test. So we would click the stress test option once we've applied the undervolts, and we will be selecting the CPU stress test with AVX2 enabled. So the first thing you're going to notice here that the current throttled and the power throttled relate to the power settings of the ICC Max and also the PL1 and PL2 short and long term duration settings that we made in BIOS. I'd recommend that everybody makes the settings in BIOS as shown at the start of this video, and we can then make adjustment to the actual undervolts only in the Intel XTU utility. So what it does is essentially modifies the profile and adds a profile into the actual device manager. If you were to look in device manager, look at software profiles, it actually modifies the actual voltage within that setting there. If you go back into your BIOS and check the undervolt application, it will remain the same. So it essentially overrides the BIOS setting on the particulars that you set within the application itself. So you can see we've got the stress test running. It will come up with the package temperature, which is just on the right hand corner here. You can see the current temperatures fluctuating just there, and when once the stress test is run, to save you sitting through the full 5 minutes which we're going to run each application during the course of this video, you can see that the CPU test passed, and that's what we're looking for. So on to the first change. So in this change we're going to make another change. We're going to add another offset of minus 0.005. So the next change we'll make is minus 0.055, and then once we've done that we'll just click on apply. What we'll then do is we'll move on to the stress test again. And then we'll run the AVX2 stress test, and 5 minutes is sufficient. You'll know if it's passed or failed when we're at this point of time. So the course of this video we're going to apply different undervolts just to show you exactly how it works and the process of actual stress testing, and just to ensure that our system is happy. Now remember, the package temperatures, even though still relatively low, actually will be much lower in gaming. So remember, the CPU is being stressed at a maximum level throughout the course of this test, and you also see the P-core frequency fluctuate as well. So remember, we synchronized all cores at 5.5. It doesn't mean to say that during the course of a stress test they're going to sit at 5.5. They'll fluctuate anywhere between 5 and right up to 5.5. Now if the test does fail, the test would fail relatively quickly from previous experience. If it is undervolted excessively, the PC will reboot, and then Intel XTU will restart on the next reboot, and it will revert everything back to the default settings. So there's nothing that's going to damage your CPU in this. It will essentially has fail-safes built in to protect your system. So once the stress test is run, you can see here that the stress test has passed with AVX2, and this is exactly what we're looking for. You can then look at the overall package temperature just at the bottom on the graph, so you can scroll the mouse across and you can refer to that. So what we're going to do after each stress test, we're going to run Cinebench R23, and you can see in this instance it's running, and it's going to produce an overall score. Now the score on my system is going to be slightly lower than it would be normally due to the fact that I'm running screen capture software on the system as well, which is probably going to knock the points down by about 300 to 400. So at the end of the first test we've got 39005, and that's on the undervolt of 0.55. So on to the next step, it's exactly the same thing again, back into Intel XTU, and you can see we've got the disclaimer we just need to click through. We are on advanced tuning and we are just going to dial in another 0.005 undervolt. Once we click on apply, we then click on stress test, and then once again we would select the AVX2 stress test, which will run for 5 minutes. So the first thing you'll see, package temperature shoots up and then it starts coming down during the course of the test, and once again you can monitor the actual package temperature by looking at the live window on the left hand side. You can scroll your mouse along the graph at the end and you can just look at the fluctuations in temperature. So remember, what we're looking for is consistency. Lots of people ask, where do we stop, what score do we stop at, and really it's down to what works best for your system. If you're happy with the temperatures and you're happy with the results, then ultimately that's good enough. You don't need to undervolt too much. Undervolting too much can essentially cause starvation of power to your system, which may cause problems. So once again we can see that the stress test passed, no issues once again. Onto the Cinebench R23 test. So this is where it becomes a little bit interesting. So as we dial out slightly more undervolt, so we're adding a 0.05 again, we can see that the actual benchmark outcomes become a little bit skewed at points. So you would think that at this point the benchmarks would improve, when actually the benchmarks can change slightly depending on the actual frequency and the undervolt. So on to the next step. So once again back into Intel XTU, and as you probably already figured out, it's repetition, so we are now dialing out another minus 0.005, and once we've clicked on apply we then click on stress test. We're then running the CPU stress test with AVX2 again. Now if the test does fail, you would see that the test fails relatively quickly. It doesn't run for long, probably less than a minute before you actually see that the test has failed. So what do we do in that event? So what we need to do is we then need to dial back to the previous levels. It's very unlikely at anything below minus 0.07 or 0.08, depending on your silicon quality, that anything's really going to fail before that point there. I would also recommend as well that you take a note of each outcome of each test. So make a note of the actual amount of undervolt you dialed out. Do it in the notes on your phone, which is what I do, or a good old-fashioned pen and paper. Make a note of the outcome of the Cinebench score as well, and what we are doing now is we're actually tracking the outcome of the results. So you can see that we've skipped through the 5-minute test again, just coming to the end of the test. You can see that the temperatures are starting to reduce as we would expect, and then what we would look for is an improvement in the actual overall score. So onto the finality of the test, and you can see that the stress test passed once again. So we're looking obviously for this green pass section just here, and we can then review our temperatures just along the line just here throughout the course of the test. Remember, this is a stress test, so remember the CPU is probably under much more strain than it would be in reality on any gaming session or any productivity session. So running Cinebench R23 again. So I'm just doing one pass on here, but I'd recommend you do a few passes on it, leaving it to cool slightly in between, or you can actually run an extended test if you wish to do that, just so you get an example of exactly what sort of power level is going to be running at and what sort of temperature is going to gain overall. So the score on this one is 39005, so it's pretty much in line with what we started off at. So on to even more undervolting. So once again we are going back into Intel XTU, and we would click on the I agree section. At this point we're dialing out another half a degree, and we are now at minus 0.070. Once again we're into stress testing again, and we'll be running the stress test as previously. So the package temperature pretty much hits 70 degrees during the course of all of these, but you can see now it then dips down. So the overall CPU package temperature now is at 66, so it's significantly reduced from the original starting point of 0.05. And once again we can review that at the end. We can scan across that graph and we can just have a look at what the temperature range was during the course of the testing. So once again, I've accelerated the 5-minute test, so we don't have to sit through all of that, so you can get an idea of the actual utilization graph just along there. And you can see that the overall package temperature is still sitting well below 80, even though we come to the finality of the tests, which is very good. And remember, before the BIOS updates and before the undervolting, you know, some of these processors were hitting temperatures and hitting firmware throttle during the course of this test, and actually failing even with no undervolt applied, with a standard Asus BIOS, and even with the Intel default settings. I've actually run this with the Intel default settings, and the test has failed on numerous occasions, which is actually quite worrying. So undervolting and syncing all cores certainly is a way forward. So reviewing the overall package temperature graph, as you can see just here, it's quite consistent and it's starting to look much nicer now. So onto Cinebench R23 again. I wouldn't get too hung up on the figures themselves. What I would do is I would try and concentrate on achieving a good score, and I would also try and look at concentrating on achieving stability on the system, and you are looking for a reduction in temperatures to ensure your system operates at the optimum. So we've had an improvement in the figures this time round, so we're at 39338. So onto another example of the Intel XTU undervolt. So once again we're clicking through a agree. We are now going to dial it out to minus 0.075. We're then going to click on apply. Once we've done that and we're happy with that, we then click on stress test, and we are going to run the CPU stress test with AVX2 again. And you can see the example where it places the CPU processor under extreme stress testing. So once it's running, you can see that we're hitting that current throttle and the power throttle due to the implementation of the ICC Max and also the PL1 and PL2 settings that we physically set in the BIOS. So that's essentially what it's telling you here. If you were to run the standard Asus overclock profile, there would be no restrictions on there, and the test would potentially fail, or it would firmware throttle during the course of the test. And you can see now that the package temperature is looking much nicer. So accelerating the test to the end again, you can see we're into the remaining 23 seconds now. The package temperature is fluctuating a little bit now, but it's around the 70 to 78 degrees, once again well below the 80 degrees level. The graph's starting to look much more consistent as well on the actual package temperature graph on the left, so you can see it's looking much more consistent towards the end of the test now as the undervolt begins to do what we intended. So you probably figured out by now there's lots of repetition involved in the testing aspect of things, and the reason why I'm using Intel XTU is that if we weren't using XTU to make the changes to the undervolt, we would have to keep applying the change to the undervolt in BIOS, and would need to keep rebooting the PC and then launching a stress testing application. And once again, Intel XTU is an excellent stress testing application to use. So onto the Cinebench multi-core test again, and we are running through one pass. And the outcome of this particular test, we are now at 39345, so the actual testing figure is improving. So we're now back in the Intel XTU application, and you can see that we have now set the undervolt to minus 0.80. Just still got the information from previous test just in there that passed. So what we're going to do, we're going to start testing again. And you can see that once again we have the starting point. Package temperature hits around the just under 80 degree mark. That's reducing consistently, and you can see the package temperature is now hovering around under 70 degrees. So the more extreme the undervolt, the less power the CPU requires to operate. A little bit like tuning a car engine, so there's a certain tolerance built into vehicles' engines, and if you want to tune your diesel engine to operate more efficiently, you can go to a garage and you can have it tuned, and you will get more miles per gallon. And essentially in the same respect, an undervolt does exactly the same thing with the CPU processor on a bit more of an advanced level. So we're using less power to be more efficient to achieve the same overall results. Because we're producing less heat and we are stressing the CPU less, we are achieving a higher efficiency results on the overall benchmark. Hence we are receiving a higher score on the actual Cinebench R23 test. So finally you can see that the AVX2 test passed. At this point we're going to just have a look at the final score here. I would say that just find a level that's happy for you. If you start going beyond these levels, then you're going to hit a point where obviously you're going to have to dial it back, because the CPU will probably start either blue screening or we are essentially starving the CPU of too much power. So a score of 39414. In the real world, if I wasn't running benchmarking software, it would be much higher. So as always in my videos, I like to use a 3D Mark benchmark run, in this instance using TimeSpy. The reason I choose TimeSpy is because it has an excellent physics test at the end. So just skipping through the first two graphics cards tests here. Once you've found a suitable undervolt for your system, and remember on this particular example we ended up on a negative offset of minus 0.80, which tended to produce the best Cinebench outcome. We passed the stress test, and just as a final example as to how it would compare in a real game world scenario, you can see here that the final score is 35590, and it's an excellent outcome on TimeSpy. So thank you once again for watching, and there are some links in a moment to other videos which I'm sure you'll find of help. A huge thank you to all channel supporters, and if this video has helped you, it would be massively appreciated if you could leave a like, subscribe and share. Until next time, take care, and I'll see you again soon.